All right, so today we're going to figure out if our inducer motor has failed or if it's another problem. Today I'm working with a Train Run True furnace. What I'm going to do is I'm going to start by undoing these two screws right here, and we're going to open up that front door. So right now what we're looking at is the inducer motor. So the fuel comes out, whether you're using natural gas or propane, comes out of this tube right here, shoots through these burners and goes through the heat exchanger. This inducer motor is actually pulling a vacuum, pulling the combustion gases through that heat exchanger. And it's going to come out through here, and it's going to go up through this vent piping out through the roof. So what we're looking for today is to see if this inducer motor has failed or if it's going to be a different issue. Before we get started, make sure your thermostat is set to heat and auto, and make sure it's about 5 degrees below whatever the thermostat's reading inside your house. That way, just for testing purposes, we know it is going to call at this control board for heat. The first step to check to see if your inducer motor is bad is to see if it will manually spin freely. Sometimes you can do it right here, or if you need to, you can turn off or unplug the system before testing this, but you can try to use a tool or something small enough to fit in between there to see if you can manually spin this. But if it's not spinning freely, we need to remove the furnace venting on top of the furnace by removing the screws that hold it in place. I have 3 screws, one here, here, and on this other side, that hold the venting in place. So I'm just going to quickly remove these. So make sure you have the power off. And we're going to go ahead and take the venting off. So while looking down into the furnace, we're looking for any debris or broken blades that may be obstructing the wheel. I like to look down there with the flashlight while trying to spin the motor to see if there's any debris obstructing its movement. Or if you do see any debris, you're going to want to remove that. So what we're going to do is we're going to spin this, make sure there's no broken blades or debris. You see a spider that may have gotten burned on there. We'll have to get him off of there. But there's no major rust, no broken blades. Everything looks good. We do have some debris right there. I'll have to vacuum that out just to make sure it doesn't keep building up. But other than that, we're looking good. Let's put this vent back on. If you have an 80% efficient furnace like I do, which you can tell by you got a metal venting, you should be able to see down into the furnace to see the inducer motor blades. But if you have a 90% or more efficient furnace, then your inducer motor is likely going to be down below and you won't be able to access it that way. So you're going to have your burners up here, and it's actually going to go down to the secondary heat exchanger and then go out. But the way to tell that is you're going to have PVC connectors, one for intake air and one for combustion air leaving. Now that we have the venting put back together, if you have removed any debris and it's now spinning freely, you can try it again. Go ahead and plug the furnace back in, let it start back up, and if your inducer motor starts, then awesome, you fixed the issue completely. If you try to turn the motor and there's no debris or broken blades in there, and it still won't spin, or it's very hard to spin, more than likely you've got some bad bearings in there, and you're going to have to replace this motor. Now, if it looks like this and it will spin freely, but it's not working when you set your thermostat to heat, then there are 3 main things we need to check. So you're going to pull out your meter, set it on volts AC, and you're going to check between C and W. C is your common, W is your heat, and you're going to have around 24 volts. I've got 28.3, so I know I'm getting a call from my thermostat in order to turn on the heat. So we're going to move on to this step. If you do not have around 24 volts to this, then you know something else is wrong and you need to go from there. Next, we need to check if we've got 120 volts to the inducer motor itself. So I'm going to go ahead and plug it back in, but before I plug it in, I've got the power off. I'm going to disconnect this harness that's got the 120 volt power going to it, and I'm going to check with my probes right there. Okay, so I've got it disconnected. I'm going to restore power now. Okay, so I just plugged it in, and you should be So I've got those plugged in. I've got 122.8 volts going to my inducer motor. So I know I've got power coming from the board to the inducer motor. So it's both getting a call for 24 volts from the thermostat, and it's got 122-ish, 123 volts going to the inducer motor. So we know it's getting proper power. So the next thing we need to do is we need to check this capacitor. So I'm going to unplug this and plug it back in, and I'm going to disconnect power completely. A quick note, I've got this plugged back in, but if you were not receiving 120 volts here, you would follow these wires all the way back to the control board, and mine plug in right over here. My wires come back into this harness, and the middle two wires, the black and the white, say INDN for ignition, or inducer neutral, and INDH for inducer hot. So you've got your hot neutral wires right there. That is where I would measure. I would take off this harness completely with the power off, stick my probes in those two middle ones just to check to make sure I've got 120 volts coming out. If I do not have 120 volts coming out there, and you've waited long enough for the heat to start turning back on, then you know you've got either an incoming power problem or your board is bad. So you need to kind of trace it back to make sure you've got 120 volts coming in there. So let's put this back together. And anytime you connect or disconnect power or a harness or something like that, make sure your power is off. Lastly, we need to check the capacitor on the side of the inducer motor, if there is one. Note that not all inducer motors will have a capacitor. We do have one. Ours is right here. If you do have a capacitor, it will look like the silver one I have, or it might be a little black box at the bottom of the inducer motor. It'll be a little black box with two terminals going to it and two power wires like this one. So what I'm going to do is I'm going to remove this rubber cover, and I'm going to be very careful not to put my fingers anywhere near the metal connections because these capacitors do hold a charge. Okay, so I'm just going to get this out of the way. I'm going to make sure the power is completely turned off. There is no power coming to my system. And I'm going to use an insulated screwdriver in order just to touch the two terminals, one to the other. Okay, so no power going to the system. If you do have power going to the system, or if it does have a charge in the capacitor, then you'll know it'll spark on you, and you can see that could have been that right there was a capacitor that had a charge to it. That would have been a bad day. Sorry, it's a little blurry. That would have been a bad day if I hit my finger. It is significantly worse than sticking your tongue to a 9-volt battery. So after discharging the capacitor by touching both terminals together with the insulated screwdriver, obviously make sure your finger's not touching that metal. You're going to want to take off your wiring connections. Got 1, 2 wire connections. Then we're going to measure from each terminal. We're going to set our meter to microfarads, or UF. We go from one side to the other. And I've got a 5 microfarad capacitor. It's reading 4.98. Okay, and if you want to see what yours is rated for, you can see it on the side. If you just want to take it off the inducer motor, you can read it on the side of the capacitor, what it's rated for. So now we're going to go ahead and replace these capacitor wires. And we can put this rubber cover back on. It can be a pain in the butt, but I'm going to leave it on because it came that way. Something to note, the 5 microfarad capacitor, it usually has a plus or minus 5 or 6% that to be within range. So it could be plus 6% or minus 6% of the 5 microfarads. So it'll be anywhere between 4.7 to 5.3 microfarads is your okay range. If you get outside of that, you need to go ahead and replace it. So hopefully by now you found the problem. If you've checked over everything we've discussed and you do not see any issues with taking the measurements and you check the capacitor, the power coming in, you know that you're getting 24 volts call, you're getting 120 volts going to the inducer motor. You know you don't have any debris or broken blades, the bearings are not messed up, then you know it's probably not going to be the inducer motor that is going bad. More than likely, you're even looking at either looking at the control board or incoming power disruption. Just a pro tip: if you do have to replace this inducer motor, the 90% efficient furnaces will come with usually come as a full assembly, just as one set piece that comes together. You have the option on the 80% furnaces normally to buy the motor and the blower wheel. I recommend buying both. What that's going to do is the wheels kind of get seized onto the shaft of the motor. So I would cut through, like with a sawzall or a oscillating tool, cut through the shaft of that motor, and that'll let you take it out of the housing. Then you just start brand new with the motor and a wheel. The wheel's not that much more expensive, but that way it'll make your life a whole lot easier than trying to get that wheel off. I hope this helps. I hope it brings value to you, which is always my goal. If you need any help with this, feel free to give me a call at 901-483-9500. We're Beers HVAC, here to help. And if you see anything that is missing that I missed in this video or that needs to be added, please let me know. I'm here to learn. As always, I'm here to help. I may have just skipped over something, so put it in the comments. That way I know that I can add it to the video. Awesome. Thank y'all so much.